Alrighty, a relative max occurs at a critical number where the function changes from increasing to decreasing. See right here, this is a relative max. All right, do you see how it goes from increasing to decreasing? There's always a critical number between that. So if I want to find, from this, you find critical numbers, and then you check to see if I go from increasing to decreasing, it's going to be a relative max. Where here, a relative min occurs at a critical number where the function changes from decreasing to increasing. So a relative min you have right here, it's a critical number right there where its slope is 0. And then it goes from decreasing to increasing. Remember, decreasing means the slopes are negative. Increasing means the slopes are positive. So if I want a relative min, I first find critical numbers, and then I got to find if these slopes go from negative to positive, it is a min. If the slopes go from positive to negative, it's a relative max. Find all relative extrema of the function. Write the coordinates and tell if they are a relative max or min. So if I want to find extrema, extremas are relative max or min, plural. So let's just find everywhere you could have it is a critical number. So anywhere you could have it, a max or min is a critical number. So first let's find critical numbers. To find critical numbers, we have to find where these slopes are 0 or the derivative equals 0. So first step is we find the derivative, which would be 9x squared minus 4. Then we want to know where that equals 0. All right. Where that equals 0 are critical numbers. All right. Now if I factor 9x squared, you hopefully know that's 3x minus 2 and 3x plus 2, if I factor that. And when I factor that, okay, now I set each factor equal to 0, and those will be my critical numbers. So when I solve this, I add 2 over, I get 3x equals 2. You're going to minus 2 over. You get 3x equals negative 2. And then you divide by 3 each of these. And you get x equals 2/3 and x equals negative 2/3. These are both critical numbers. These are spots that could be relative maxes or mins. Our next thing is to see if they are maxes or mins. And what we tell is we see how they change increasing and decreasing. So I'm going to make a little number line here. This one will be negative 2/3. And right here we'll put a positive 2/3. All right? And what we're going to do here is what we know is these are the only possible spots where your slopes can change, positive and negative. So I'm going to put a value in here, from here, and over here, and see if the slope values are positive or negative. So I'm going to find f prime, something in this interval. Let's just make it -1. That seems pretty easy. And then in this interval, I'm going to find f prime 0. That's an easy one to find in this interval. And for this interval, I'm going to find f prime, an easy one to be 1, because those are values in each interval. -1's easy for this interval, 0's for this interval, and 1 for this interval. So as I do this, well, when I plug it in here, the function is be 9 times x squared minus 4. And when I plug in the -1, what do you notice? Let's see here. I get 9 times 1 minus 4, which is equal to 5, which is positive. What that means, if it's positive, that means it is increasing here. All right, so this is a positive value. Now let's try the next one. If I have 9 times 0 squared minus 4, that would be 0 minus 4, which is negative. Okay, -4, which is a negative value, so this is negative, so we would call this decreasing because the slopes are negative there. And the last one, 9 times, let me go back and get that off there. 9 times 1 squared minus 4, which would be 9 minus 4, which is 5, which is a positive number. So if it's positive, we know this interval is increasing. So what we notice here, it's going to be going up, then down, then up. So the picture of this would kind of be like it's going up, then it's going down, and then it's going back up, is what this is trying to say. It's going to go up, down, up. So these are your critical numbers. So can we tell now that right here and right here, can we tell what those are? Well, to find those values, well, we know this is going to be a max and this is going to be a min. Alrighty. So we now need their coordinates. All right, here's where it gets a little bit trickier. We know the first one is going to have a relative max at the coordinate negative 2/3, comma, something, and it's going to have a relative min at the coordinate 2/3, comma, something. So we know that because the something is because negative 2/3, we just said this one right here is that max, and this one right here is that min. How do we find these values, the outputs? Well, now we have to go all the way back and find the values of f of negative 2/3 and f of positive 2/3 and crunch those. And for those, I would need a calculator. I mean, it'd take a long time without. So when you plug that in your calculator, this becomes negative 6.2, repeating, and this one becomes negative 9.7, repeating. It'd just be a pain to do that without a calculator. So those values go right here for the coordinates. So this would be negative 6.2, and this would be negative 9.7. So this coordinate would be your relative maximum, and this coordinate right here would be your relative minimum. This is a long process, but this is a big idea in calculus.